Well, hello everyone. Welcome to our channel 361 Physics, and here we are presenting the first video of modern physics, and it is particularly related with the photoelectric effect. And in this video we are trying to make uh, some revision so that we can easily tackle some MCQ problem. Okay, so let us begin with some recalls. So here in this part, I have mentioned some properties of light, and as we know that light can show two kind of nature or feature. One is wave nature and another is particle nature. Wave nature is confirmed by the phenomenon like interference, diffraction, and polarization. Okay, and particle nature is confirmed from the you can say that photoelectric effect shown by the light, Compton effect, and Raman effect. Okay, so these are basic things, and these all things are um, also the candidate for the MCQ questions. Okay, so now let us move further, and here the another property related with light is light composed of uh, um, you can say that bundle of energy, and each um, the bundles are known as photon, and each photon contains energy equal to h nu. It is nu. In lots of book, frequency is represented by this particular symbol. This is nu, or in general it is represented by hf, where f is the frequency, and as we know that c is equal to product of lambda and f. That's why we can replace this frequency by c by lambda. So another form of energy is s times c by lambda. If you want to find the energy of n number of photon, then we just have to multiply here by n. Okay, this will be nhf. Okay, now let us move further. The momentum of photon. Okay, so momentum of photon is given by this form, which is equal to hf by c. If you place this f below this c, then you can replace this by the ratio by lambda. That's why the momentum of photon is h by lambda. And if you want to remember this, then just recall the de Broglie wave equation, where we have to write this expression for de Broglie wavelength as the ratio of Planck's constant, and this is what momentum. Okay, and the value of Planck's constant is 6.62 into 10 raised power minus 34 joule second. Okay, just this is just a revision. Here is another term, kinetic mass of photon. Okay, so kinetic mass of photon can be expressed as the ratio of product of uh, Planck's constant with frequency and the square of velocity of light. Well, this is known as the dynamic mass of photon. Okay, dynamic mass of photon or kinetic mass of photons are same thing, and its expression is this or this one. Okay, after rearrangement of frequency and the velocity of light, you can replace the uh, this expression by h by c by lambda. Okay, now we are going to discuss particularly here photoelectric effect. What is photoelectric effect? So as we know that if suitable, sorry, not suitable, we can say that if radiation of suitable frequency or energy strike on a substance, then a part of energy is utilized to just pull the electron on its surface, which is this part is known as threshold energy. Yeah, and this expression is used for used to represent the threshold energy. Here f naught is its threshold frequency, and the rest of the energy is utilized in the form of kinetic energy of electron, or a kinetic energy of ejecting electron. Okay, these are electrons. Well, so from Einstein's equation we can write here hf equal to 5 plus e ke, where k is its kinetic energy of electron. And uh, from this expression we can say that this expression also uh, follow the conservation of energy. Yeah, so here phi can have been replaced by hf naught, and here kinetic energy is half mv square. It can be replaced by ev naught, where uh, ev naught and this parameter v naught, or another in another book it is represented by vs. Both are same thing. V naught or vs is known as stopping potential. Stopping potential. Okay, so this is the value of stopping potential, or representation of stopping potential. So from these two expression we can equate these two parameter. ev naught equal to half mv square. Well, now let us discuss some notes here. Energy of photoelectrons is independent of intensity of radiation. Yeah, so if we increase intensity, then energy or kinetic energy of electron remains constant. That means energy does not depends upon intensity. Okay, it does not depends upon intensity, but the number of electron ejection depends on the intensity. And as the number of electron increases, the current through the circuit also increases. That's why we can say that photoelectric current, or simply photocurrent, or number of photoelectrons ejection depends on the intensity of radiation, directly depends upon radiation. So if we plot the variation of current, photocurrent, and intensity, then that will be a straight line passing through the origin. And here we can see that for different intensities, the stopping potential is same. That means the stopping potential also does not depends on the intensity. Okay, but you can see here the current value of current increases for different value of intensity, or increasing value of intensity. Okay, so and this is just a recall. Okay, now you can see here another note. Energy of photoelectrons depends on the energy of photons, or frequency of photons. That means energy of photoelectrons represents here kinetic energy of electrons. Okay, so kinetic energy of electrons one depends on the energy of striking photons. So if you see, sorry, okay, so if you plot a variation between the potential and current, the nature of graph will be uh, this kind of graph. Here v1, v2, and v3 represent three different stopping potential. And for three different stopping potential, the value of current, this is value of current which is same. And here f3, f2, and f1 represents the frequency. So here v1, as v1 represents the stopping potential, smallest value of stopping potential, so its corresponding frequency is f1, its corresponding frequency is f2, and its corresponding frequency is f3. Okay, and another graph is quite important, and this graph represents the variation of frequency with stopping potential. And here the intersecting point, if you see here, the intersecting point always represent the stopping, sorry, not stopping, represents your threshold frequencies. Okay, so for metal 1, f01 is its threshold frequency, and for metal 2, f02 is its threshold frequency. Okay, so that is the revision of photoelectric uh, effect. Now we are going to discuss about de Broglie hypothesis or wave particle duality. So according to de Broglie, each particle can show wave and particle behavior. So according to de Broglie, the wave associated with any particle is known as de Broglie wave, and its wavelength is given by h by p. And for the modification, you can replace this p by 2mke root over, and this can also be replaced by qp, because as we know that kinetic energy for electron is ev, but for another charged particle is this is qb. So we can easily replace this ke or ek by qb. And for especially for electron, if you measure the value, you will get this expression lambda equal to root under 100. This is 50 by v, and this is in unit of angstrom, which is 10 raised to power minus 10 meter. Okay, so this is just a revision. That's why we are not dealing in detail here. uh, so here another expression for de Broglie wave. This expression is especially for neutral atoms, neutral substances which do not have charge, and atoms, neutral atoms. So for neutrons and a neutral atom, the kinetic energy can be expressed as the product of kT. Here K represents Boltzmann's constant. So in previous expression, this expression, we can replace Ek by kT. So this is another expression, and this is special expression for de Broglie wave of neutral atom and neutrons. And the Davisson experiment and GP Thomson experiment shows that the de Broglie wave, theoretical value of de Broglie wave for electron and experimental value of de Broglie wave is quite um, quite equal. That's why this verifies the de Broglie hypothesis. Okay, now let us do some MCQ. The stopping potential V naught versus frequency plot of a substance is shown in figure. The threshold wavelength is. छ अब हामी यसमा के बुझ्दैछौँ भने क्वेशनले के भन्दैछ, यो भेरिएसन हो, स्टपिङ पोटेन्शियल यहाँ 1-2 भोल्ट छ र यहाँ फ्रिक्वेन्सीको भेरिएसन छ र हामीलाई के निकाल्नु छ भने थ्रेशोल्ड वेभलेन्थ निकाल्नु पर्ने छ। अब थ्रेशोल्ड वेभलेन्थ निकाल्नु पर्ने छ भने हामीले सबभन्दा पहिला थाहा हुनुपर्छ यो के हो। यो इन्टरसेक्ट हुन साथ यसलाई भन्छ, हामीलाई यसले दिएको छ फ्रिक्वेन्सी, थ्रेशोल्ड फ्रिक्वेन्सी। थ्रेशोल्ड फ्रिक्वेन्सी दिन साथ हामीले के बुझ्नुपर्छ भन्दाखेरि अब फ्रिक्वेन्सी हामीलाई थाहा छ। ओके, थ्रेशोल्ड फ्रिक्वेन्सी थाहा छ भन्न साथ अब हामीले यो पनि के युनिटमा छ त्यो पनि ध्यान दिने। दिस इज 10 raised to power minus 14 हर्ज को युनिटमा छ। अब थ्रेशोल्ड फ्रिक्वेन्सी थाहा छ भने सी बाई लेम्डा भन्ने एउटा फर्मुला हामीसँग छ। सो लेम्डा नट लेख्न पनि सकिन्छ। सो लेम्डा नट इक्वल टु हुन्छ सी बाई एफ नट, अनि सी त 3 into 10 raised to power 8 जेनरली युज गर्छ। एफ नट भनेको हामीलाई थाहा भयो 5 into 10 raised to power 10 raised to the power 14 भयो। अब यसलाई सल्भ गर्दाखेरि आउँछ हाम्रो, सल्भ गरेर हेर्ने हो भने यसले हामीलाई दिन्छ। जस्तो सजिलोको लागि के गर्ने भने नि सल्भ गर्ने तरिका पनि भनिहालौँ। सजिलोको लागि यो 3 लाई हामी 30 लेख्दियौँ। ओके, अनि यहाँ कति हुन्छ 10 raised to power 7 हुन्छ, अनि यो माथि लगाइदिने यसलाई। यसलाई हामी यहाँ माथि लगिदिन साथ के हुन जान्छ भन्दाखेरि 14 हुन जान्छ एन्ड देन यहाँनिर हुन्छ 5 ठीक छ अब यसले सल्भ गर्दा 5 6 आउन साथ लगभग 6 भएको एन्सर नै हो 6 भएको एन्सर भनेको बी त्यसैले यो एन्सर हाम्रो करेक्ट एन्सर हुन्छ यसरी क्विकली गर्न खोज्नु पर्छ कुनै न कुनै वेमा हामी सकेसम्म छिटो गर्न सकिन्छ भने त्यही वे फलो गर्ने हामीलाई डिटेल सल्भ पनि गर्नु पर्दैन एमसीक्यू सल्भ गर्दाखेरि well now let us move to question number 2 and here we can see that the question says when the amplitude of light wave incident on a photometal sheet is increased then the photoelectric current increases the photoelectric current remains unchanged the stopping potential decreases the stopping potential increases okay so as we know that intensity is directly proportional with square of amplitude and current is also directly proportional with the intensity. That's why we can say that as amplitude increases, which implies the intensity also increases, and it uh, uh, we can say that intensity and current as they are related with each other, so directly related with each other, that's why current also increases. ठिक छ यसको मतलब के हो भने जति बेला हामीलाई के थाहा छ भने इन्टेन्सिटी र एम्प्लिट्युड इन्टेन्सिटी एम्प्लिट्युडको स्क्वायरसँग डाइरेक्टली भ्यारी हुन्छ र अर्को कुरा हामीलाई थाहा छ करेन्ट र इन्टेन्सिटी डाइरेक्टली भ्यारी गर्छ त्यसो हामीले यसलाई जोड्दियौँ त करेन्ट फोटो करेन्ट है फेरि एम्प्लिट्युडको स्क्वायरसँग भ्यारिएसन हुन्छ भन्ने टाइपले जोड्न सक्छौँ त एम्प्लिट्युड बढ्यो भने करेन्ट पनि के हुने रहेछ बढ्ने रहेछ सो फोटो करेन्ट इन्क्रिजेस ओके सो हाम्रो करेक्ट एन्सर हुन्छ answer A. Well, now question number 3. In this question, it is said that there are n1 photons of frequency nu1 in a certain beam of light and n2 photons of frequency nu naught in another equally intense, this is intense beam of light. Then which is correct? Which relation is correct? So as we know that intensity is the ratio of these all parameters. Intensity is the energy per second per unit area in generally. Well, we can say that intensity is equal to k times. Suppose these two parameter to be constant is equal to k times energy, and for first case I1 is equal to k times an energy of a photon. If n1 is the number of photons, then n1 h is constant mu1, and for another one we can write k times n2 h mu2, and both are equally intense. That means we are given to equate I1 and I2. हामीलाई यो I1 र I2 इक्वल गर्न दिएको छ. So n1 h nu1 equal to n2 h nu2 हुन्छ. यो रो क्यान्सल भएर गयो. अब एरेन्ज गरौँ n1 by n2 equal to nu2 by nu1. So यो प्याटर्न को हेर्ने हो भने nu2 by nu1, n1 by n2 nu2 by nu1 कुनै छ छैन. त्यसो भए यसलाई एक्सचेन्ज गर्दियौं. nu2 लाई माथि nu1 लाई तल गर्ने हो भने लेट मी ड्रप दिस पोर्सन. ओके, अब त्यस्तो गर्ने हो भने यो nu2 nu1 by nu2 लेख्न साथ एक्सचेन्ज भयो नि त. अनि यो पनि एक्सचेन्ज हुन्छ. एक्सचेन्ज हुँदाखेरि के हुन्छ n2 by n1. सो यो त करेक्ट एन्सर हाम्रो एन्सर बी देखिन्छ. ल अब हामी क्वेशन नम्बर 4 तिर पुग्छौं. Photons of energy 6 electron volt are incident on a potassium surface of work function 2.1 electron volt. What is the stopping potential? ठीक छ, यो एकदम क्विकली गर्न सक्नुपर्छ. हामीलाई के थाहा छ भने एनर्जी 6 छ अनि वर्क फंक्शन 2.1 छ अनि काइनेटिक स्टपिङ पोटेन्शियल ल यहाँ EV नट लेख्छौ. अब यो जस्ट रफली गर्छ हामी है. 6 minus 2.1 हुन्छ. अब यो EV नट पुरै सल्भ गर्न जरुरी छैन. जे भ्यालु आउँछ है त्यो भ्यालु नै एन्सर हुन्छ. यो भनेको 3.9 जस्तो आउँछ भनेको हाम्रो एन्सर सी छ. है करेक्ट एन्सर। अब हामी क्वेसन नम्बर 5 मा छौं। which graph represents the correct variation of kinetic energy with the frequency? हेर्ने प्याराबोलिक पोसिबिलिटी छैन है, सरी प्याराबोलिक भन्दा पनि यो लगेर हाइपरबोलिक नेचरको छ, यो त जेनरली पोसिबल देखिँदैन, कुनै पनि रिलेसन छ हैन फ्रिक्वेन्सी र काइनेटिक एनर्जी बीचको। जस्तो फ्रिक्वेन्सी र काइनेटिक एनर्जी बीचको रिलेसन के हुन्छ भन्दाखेरि सिम्पली हामीले हेर्ने भने फ्रिक्वेन्सी बढाउँदाखेरि काइनेटिक एनर्जी पनि बढ्छ भन्ने टाइपको रिलेसन देखिन्छ। तर के हुन्छ भन्दाखेरि सर्टेन फ्रिक्वेन्सी एक्सिड गरेपछि, जसलाई भन्छ थ्रेसोल्ड फ्रिक्वेन्सी भन्दा बढी फ्रिक्वेन्सी भयो भने मात्र काइनेटिक एनर्जी बढ्छ। त्यसो भए हेर्ने हो भने यो डाइरेक्टली प्रोपोर्सनलको ग्राफ हो जुन फिजिबल छैन, बिकज एउटा सर्टेन फ्रिक्वेन्सी एक्सिड गरेपछि मात्र काइनेटिक एनर्जी बढ्छ, यो पनि भएन। यहाँ त जिरो फ्रिक्वेन्सीमै काइनेटिक एनर्जी आइछ, यो पनि पोसिबल छैन, यो त नेचर पोसिबल नै भएन। यहाँ हेर्ने हो भने यहाँ ठिक छ, सर्टेन फ्रिक्वेन्सीसम्म नो काइनेटिक एनर्जी एनर्जी छैन, किनभने यहाँनिर थ्रेसोल्ड फ्रिक्वेन्सी एचिभ भयो। त्यस पछाडि के हुन गयो, काइनेटिक एनर्जी ग्रेजुअली बढ्दैछ। त्यसो भए करेक्ट एन्सर हुन्छ answer D. Okay, so from question number 5 we are confirmed that option D is our correct option, because we can see here up to V, up to this point, up to point, suppose this is A, then up to point A there is no kinetic energy. That means here A point represents the threshold frequency, and after exceeding this value the kinetic energy gradually increases with the increase of frequency. That's why correct representation of variation of kinetic energy with the frequency is graph D. Well, this is our first video of photoelectric effect, and we are preparing lots of MCQ related with different topics which we think could be very helpful for the entrance preparation. Well, stay tuned and please subscribe us. Thank you.